So my friend showed me this video a while back, and taking inspiration from someone, I thought I should make a robot out of it. Robots are fun. Wet floor signs, well, they serve their purpose. However, it takes valuable time to find the wet floor, and then you also have to pick up the sign and move it there. So I'm going to spend some time electrifying this analog, mindless and plastic wet floor sign into something a little bit smarter, and hopefully not worse. Did it just move? Enough messing around, let's get started. After receiving my wet floor sign in the mail, I promptly set it up, and it was now time to find all the required components for the build. I need a couple of stepper motors, a microcontroller, the moisture sensor, the motor drivers, an ultrasonic sensor, throw in a bunch of wiring, and after a few minutes, we now have the basic electronics done. Unfortunately, that was the easy part.
It's a little bit messy, but as long as it works, I'm not complaining. Oh, I just killed one of my nice Arduino boards. It gets incredibly hot, even with the heatsink, and I don't even know what I did wrong.
Next up comes the software.
I know there will be mixed opinions about using ChatGPT for programming. I used ChatGPT 3.5 for about 2 hours. I almost got this working, and within 50 minutes of using ChatGPT 4, I got the whole thing working as is. I mean, I couldn't be more pleased.
For context, I told ChatGPT what components I was using and gave it a briefing on the project. I basically asked for code that made the robot move forward using the 2 stepper motors, turn when the ultrasonic sensor detected a wall, and then stop if the soil moisture sensor detected water.
So the robot is moving forward, it detects an obstacle, it moves and turns to the side. This will trigger, and that stops. The water dries up, and it continues moving. Oh, that's so awesome. The system runs off 12 volts, so that means we can use AA's or 18650 cells. It's versatile. I found this acrylic sheet in storage, and I think I might design some hinges. Not hinges, but brackets that mount this to that. Then we can mount the electronics to it. Not bad, not bad. So instead of moving the electronics, I'm just gonna... Oh yeah, that was much easier. So there is a little bit of a gigantic problem, several of them actually. We need 12 volt power for the motors, and I guess the Arduino too. The soil moisture sensor, well, that needs to be mounted as well. And then ultrasonic sensor is not gonna be doing much if it's pointing at the sign. Here's the plan. Ultrasonic sensor first, then we do the wheels, then we can do the soil, then we do the power. Sounds good. I would like to 3D print a mount for this. I think that'd be cool.
Speaking of cool, PCBWay has some awesome services I can recommend checking out. They offer all sorts of additive manufacturing technologies and a ton of materials to choose from. Their aluminum SLS printing is super durable and sounds the part as well. Not to mention their SLA printing, which is very precise, and with the transparent resin I chose, clearly worth giving a go. With capable subtractive services like CNC machining as well, PCBWay could be the catalyst to your next level project. Find them first link in the description. After measuring the ultrasonic sensor, I designed and 3D printed a simple mount for it.
It's a little basic, but it's working so far. That's good. It's a bit fiddly. And now we're all wired up. I did invert the sensor, so I did swap the pins around. So we won't be short-circuiting anything this time. These are the adapters that go into the shaft of the motor and into the bearings on the wheels. Let's install them now.
These adapters ended up not working well at all. I had to use hot glue, which didn't help my situation. I'm unsure if I was supplying enough current to the motors, since the torque they produced was pretty low. I also made this little adapter that plugs into a 12 volt battery, which in turn powers the whole system.
Okay, we're at the final stages now. Theoretically, the entire assembly will power on when I plug this battery. 2, 1. Wow, okay, it's working. It's first steps. Or rolls. Crawls. I don't know. It's having a bit of trouble moving, but yeah, if we bridge the connection here, it should stop. And then if we take it off... Oh, okay, that's so cool. I think it needs more space. Oh, come on, it's on the water. Oh, it stopped! So, okay, I know that there's a wet floor there. Can I call that a success? You know what? I might have to. I'm sure that if I absorb this water with paper towels, it would start moving again. And there it goes! Realistically, this isn't that practical, but I've achieved a lot in the time that I've spent on it, and I have validated the concept. I would really like to do a V2 though. If you guys would like to see me build an entire custom robot from scratch, I'd be down. I mean, that seems like a lot of fun. I'd make it a little bit better than this. Thank you guys so much for watching. Hopefully, I'll see you again soon.